Hi friends, good to see you back so soon. So, we talked about the levels that biological organization is divided into. And I thought today we might dig a little deeper into this topic. Are you with me? Great. So, in this figure, you can see multiple levels of organization. Let's start from the bottom and work our way up to the top. Come on, my young biologists. Put your thinking caps on and let's go. So, starting right from the bottom, we have the structures that cannot be seen by the naked eye, not even by a light microscope. These minute structures are the basic unit of all living and non-living things called atoms. You can find them everywhere. From everything you can see and touch right now, including your cells and this screen, to everything you could possibly imagine. But is there anything smaller than this? Surprisingly, yes. They are called subatomic particles and include protons, electrons, and neutrons. These are the smallest units that join forces to build larger and larger particles. In living organisms, the bioelements usually do not occur in isolated form because they are highly unstable. I'm talking about carbon, nitrogen, hydrogen, phosphorus, and calcium. These fellas are ready to run away at the drop of a hat and destabilize. That's why the atoms of various elements combine either with each other or with atoms of different elements to achieve more stability. And what do they produce after this combination? They produce compounds called molecules. This means we are at the next level, the molecular level. But how do these biomolecules combine? Do they stand together holding hands? Of course not. They form strong chemical bonds through covalent or ionic bonding. So, the different types of bonding arrangement in these biological molecules give their structure great variety and complexity. For instance, there are two types of biological molecules depending on their masses: micromolecules and macromolecules. As the name suggests, micromolecules have low molecular weight, like water and carbon dioxide. On the other hand, macromolecules have higher molecular weight, like starch and proteins. An organism is made up of thousands of micro and macromolecules. Biomolecules are also classified as either organic or inorganic. Organic molecules contain carbon and hydrogen both, while the inorganic molecules do not contain both these elements together. Some of the most important and abundantly found organic molecules are glucose, amino acids, fatty acids, glycerol, and nucleotides like ATP, ADP, and AMP. While the inorganic molecules are water, gases such as oxygen and carbon dioxide, and minerals such as calcium, sodium, and potassium. That's quite interesting. But what happens when these macro and micro molecules come together?